that load up here. All right, there we go. Okay, so your instructions just say to simplify, which isn't very helpful. You really should say to FOIL, F-O-I-L. Did you see that in class, or have you heard that before?
No.
Okay, we're going to run through FOIL. FOIL stands for something. It's not great. It doesn't, it's you'll see here in a moment. So F stands for first times the first. Okay, so I'm going to color code these so we can make it clear. But you're going to take the first term, the x, and multiply it by the other first term, the 2x. So that's what the F stands for. All right, so can you tell me what x times 2x is?
2x.
2x squared. So the x is, because there's a power of 1 and a power of 1 there, when you multiply the x's, they are squared. You add the exponents. Is that okay?
Yeah.
Or have you not seen that either?
I didn't realize that.
Okay, good. Yeah, it's a little odd. It's like, well, why is it all of a sudden that the exponents add together? It's actually always been the case. They just sort of hide it from you until now. So we'll see that more today. So the O stands for the outer or the outside. Okay, so I'm gonna just reframe this. That's not what I wanted. So the outside are literally the ones that, like, if I asked you outside, that's the leftmost one and then the rightmost one. Those are on the outside or the outer. All right, so in terms of like, what do? You multiply x times minus 5. That sign goes with the number, okay? And that becomes minus 5x. Is that okay?
Yeah.
All right. And this does go faster. I mean, we just need to really break apart the first one. Then it's the inner for I. Inner, or the ones that are touching. So think of it that way. They're close together. All right, so let me color code those in blue. So it's like plus 3 times the 2x. Those are the inner. All right, so it's positive 3 times 2x, which equals 6x. And then L is the last one, stands for the last. Okay, last times the last, or the second times the second. I'll color code that again to make that clear here. So if you look back in your notes or watch the recording, hopefully you're like, yeah, that makes sense to me. So that's the last, that's the plus 3 times the minus 5. And the idea is that everything in the one binomial gets multiplied by everything in the other. All right. So for subsequent problems, you're going to be able to do this a lot faster and with more efficiency than this, but we're going to now combine all the results. Okay, so we're going to take the first result there, the 2x squared minus 5x plus the 6x minus 15, and you generally can combine the outer and the inner. You generally can combine these two right here, the O and the I. This is the O, this is the I. Those you can generally combine. So in this case, it's minus 5x plus 6x, and that becomes just positive 1x, like this. So this is your final answer. This is what they're looking for in the box. Now, if that felt overwhelming, we're going to do a lot of problems today. They're going to go much, much faster, but we need to do at least one very, very explicit problem and then get to the rest. Okay, so let's take a look at number 2. Number 2, get this. Okay. All right, so FOIL, FOIL, first times the first. So you're going to take this 3W and multiply it by 2W. And if you need to, you can write that 3W times 2W, and that becomes 6W squared. And that's the F. Now we're going to do the O. The O is the outside, the 3W times the -1. So that becomes minus 3W. That's the O, the outside. The inner are the ones that are touching, kind of right next to each other, the +4 and the 2W. So the 4 times the 2W. And that becomes 8W. And then the last is literally the second two ones. So +4, -1, +4, -1. So that becomes -4. And again, you can combine like terms, and usually it's the O and the I that you combine together. All right, so that's 6W squared plus 5W -4. And that's your final answer.
Okay.
All right, so I'm gonna skip 3 and go to 4. Go to 4 here next. I'm going to kind of show you another way that students start working these as they get a little bit more familiar with it. Okay, so you can write FOIL if you want. You just need to remember FOIL, so students say FOIL. But you're going to see this. You're going to see this like 5x times 4x. Like you want to draw a line showing I'm connecting the 5x and the 4x. Okay. And if you need to, you can write it out. But I'm hoping by now, if I ask you, Maris, what's 5x times 4x, what would you tell me that is?
20x to the second.
20x squared or 20x to the power of 2. Good. Then you take the 5x and you multiply it by the +2. So it's 5x times the +2. That's the O, by the way. What would that be?
10x.
Plus 10x. Now we're done with those. So now we're going to go the other, we're going to go with, for the I. The I is the -3 times the 4x. -3 times 4x. What does that become?
Minus 12x.
Good. And then you take the -3 times the +2.
-6.
-6. So the main mistake that's made here is not associating that subtraction with the number, or if there's another subtraction over here, it goes with the thing on the right. Okay. Now you just combine like terms. So it's 20x squared minus 2x minus 6. Any questions on that?
No.
Okay. I'd like you to try number 5 on your own. Let me snip that in. There's no signs to deal with. You just have to do the 4 multiplications, the FO, the I, and the L. So give that a try. And if you have questions, please ask. But I'd like to see where you're at on this now that you've seen a couple of examples worked out. How are you doing on this one?
Pretty good. I got 3x squared plus 22x plus 35.
Yeah, perfect. Really good. Okay, let's go back to number 3 and work this one out together. Again, whenever there's a subtraction there, that's the one you just got to be a little bit more observant with and know that that -7, or the negative really goes with the 7. But again, you're going to see a lot of students do this. You're going to write 4x times x, or they're going to draw this line. They're going to say 4x times x is 4x squared. Then it's 4x times -7. -7, that's minus 28x. Okay, then I usually come underneath. So it's 3 times x plus 3x, 3 times -7 minus 21. So you got 4x squared minus 25x minus 21, like that. All right, so let's have you try number 6 on your own. It's kind of like number 3. Just see where you're at. See if everything's clear. If you have some questions, please ask. But just let me snip this one in, and just let me know your final answer whenever you're ready.
I got 3k squared plus 8k minus 16.
Yeah, perfect. All right, so pretty good. Let me go to the next picture and see if there's anything else. Yeah, so let's go to number 9. 9 is kind of an exception here to some of the things we've been seeing. So we'll work on that together. Okay, so here's number 9. If you look at this, you see, okay, it's 3x plus 4, 3x minus 4. So it's the same thing except for this sign. And something different does happen here. But we're going to do the same thing as always. 3x times 3x, that's 9x squared. Make sure you always multiply those coefficients together. 3x times minus 4x is minus 12x. Positive 4 times 3x is positive 12x. Positive 4 times minus 4 is minus 16. So we're left with 9x squared minus 16 because the outer and the inner cancel. Okay, so that sometimes will happen. Sometimes they go away completely. That's the only one like that. So we'll let me see, actually, let's just check here. Make more good. Yeah. All right, so let's go to 13. 13 is kind of a little bit different than any of the other ones we've been seeing, because it's now got a x squared in there. Oops, wrong color. Let's go back to that color. All right, so the idea here is that you still FOIL. You still FOIL. It's just that, the answer will look a little bit different. You take the x squared and multiply it by the x. Okay. And what I was mentioning to you earlier is that if the bases are the same, you add the exponents. So when you take x squared and multiply by x, it becomes x cubed, or x to the power of 3, because you add the 2 and the 1, they add together. Right? Then you take the x squared times -2, and that becomes -2x squared. Then you take the 4 and multiply it by the x, that's 4x. And then the 4 multiplied by the -2, that's -8. All right, so let me know when you get caught up to this step here.
I get it.
Got it. Okay. My question to you is are there any like terms in here? And if you're not sure, I can give you some examples.
No.
There are not. There are no like terms, so this is your final answer. So in the previous problem, we canceled out. Here, there's nothing you can do. Just totally nothing available. All right. And that does happen when the x's are mismatched, meaning you've got like an x squared and an x. That does happen. All right, so let me have you try number 17 on your own, and let me know what you come up with. If you have questions, feel free to ask. It's very much like the one we just did.
I got 8x to the, or 8x cubed minus 20x minus 6x squared plus 15.
Very good. Very good. Okay. Small, like little adjustment here. Like your answer is not wrong. It's it's that you would likely see this like in the back of a textbook as the following. You'll notice I'm just switching 2 of the terms. So this is in what's called descending order. The exponents are descending: 3, 2, 1, none. This is preferred. Is your answer wrong? No, but I mean, someone grading it wants to see this.
Okay.
All right, we will do 15 and 16, but I want to do 20 first because it's more in line with what we've been doing. This is the kind of thing that you will see number 20 here at a later time in a math class, and if you don't know how to do it properly, you'll obviously make this mistake. So what you do is you actually write out the 2x minus 5 twice, like this. This is correct, what we're about to do. This is correct, okay? Anything else is considered wrong. So you definitely want to write it out and then you FOIL it the way that we've been doing it. So this is 4x squared minus 10x minus 10x plus 25. Minus 10x, they do not cancel, they combine into minus 20x. And this is your final answer. You actually, this does have a name, but we don't need to give it one right now. So always write it out, always write out side by side. So if that made sense to you, will you try number 19 and let me know what you come up with for this one?
All right.
Do you have a final answer for me on this one?
Yeah. X squared plus 16x plus 64.
Got it. All right, not too bad. Okay, so just here's how I'm thinking about the rest of the time. I want to go through 15 and 16 and then jump over to the story problems. We should be able to get all those done, but there is some you will have to do on your own, but you probably already have a good idea about how to do them. So let's look at 16 together. So here is 16. All right. So the FOIL works well for what's called a binomial times a binomial. Basically, all the ones we've been doing are binomial times a binomial. Two terms times two terms. Two terms times two terms. Two terms times two terms. Okay. This is not a binomial times a binomial. This is two terms times three terms. And the FOIL method does not work. What works is knowing that you need to take this 2x and multiply it by everything on the right. Okay, so you take the 2x, you multiply it by x squared, and that's 2x cubed. 2x times 3x, that's 6x squared. 2x times the 4 is positive 8x. Right. Now you do the same thing with the 3. You multiply each of these by 3. So that's positive 3x squared, positive 9x, and positive 12. Now, you may be wondering, why did I write it this way rather than all in one line? Any idea why I might have done it this way?
Oh, it's addition.
Yeah, and the things that are vertical, they combine together. All right. So the more complicated ones, this you have to do it this way to really see it, but the idea is that it just makes adding easier. But they've got to line up perfectly. Okay, so it doesn't matter to me though. You don't have to do it this way. You can put them all in one line. Really doesn't matter. The key though is recognizing that the 2x goes times each of these, the 3 goes times each of these, and then you combine like terms. So it's just like a more complicated problem than we've been doing. More terms, more work. Any questions on that front there?
No.
Okay, so I'll have you try one, 15. I know these aren't very exciting. A lot of math is pretty dull. But maybe the story problems will have something more interesting going on in them. But if you don't mind, give this one a try and let me know your final answer whenever you've got that.
Okay. I got x squared, or not, x cubed
Good.
plus 8x squared plus 22x plus 21.
Good. That's completely correct. All right. You should feel a lot better about these if you had any, uncertainty before. The ones we did not do, you have enough information to do them. And we can come back and look at them if we need to, but it's on to bigger and better things like story problems. And we'll work on those now. So take a look at 21. 21 here. And let's see here. Okay. All right, a square has an unknown side length. Okay, unknown side length. So we got a square here. But we don't know how we don't know its side length. So let's just call it, well, we'll get to that. All right. If its length is increased by 11 units to create a new square, a larger square, write a simplified algebraic expression for the larger area of the new square in terms of A. If A represents the length of the original side length. Okay. So these are awful to read. And you probably saw, I invited you to that SAT, ACT test prep class. These are the kinds of questions we see where there's a lot of extra unnecessary words here, but that's the way these are written. Okay. Sometimes you got to read them twice. That is a something a lot of students will do here. So they're telling you though that the length of the original square is A. Side length is A. And because it's a square, you know that both sides are A. But we actually don't care about The original. We care about this new one. And what does it say here? What does it say about its length in this new part of the problem?
The length is increased by 11 units.
Yes. So what does that mean? We can call it a plus 11 and then a plus 11. Because we don't know. We don't know if a is 1 or 10 or billion. We just know that it's a. So we know whatever a is, we're adding 11 to it to get the new answer. New side length, okay? But that's not even what it wants. And that's what makes these so difficult. It says, write a simplified algebraic expression for the area of the new square. All right, so that's what it wants. Area is base times height, okay? So the area is the base, which we'll call a plus 11. The height is also a plus 11. Is that okay? Is that clear?
Yeah.
All right, now here's what I want you to do. I just want you to FOIL this for us, please. That's the simplified part.
Okay, one second. Okay, I got a squared plus 22a plus 110.
121. 121. Good. Really good.
Yeah, that's right.
Really good. All right, let's take a look at 22. Is this the normal length of one of your homework assignments?
It's a little bit longer.
Yeah, it seems like it. But we're gonna get through most of it. It's just sometimes I'm, always curious. All right, new problem here. So it says the width of a rectangle is unknown. So you draw your favorite rectangle. It doesn't really matter what you draw. Just make sure it's a rectangle. The length of the rectangle is 2 more units than its width. Okay, so out of those first 2 sentences, you should be able to tell me which is longer, the length or the width. Which is longer in this problem?
The length.
Length is longer, yeah. But what you cannot do is you cannot be like, oh, this is the length and this is the width. You can't do that. You have to use letters. All right, now it takes a while, but they actually tell you the letter down here. So let's keep reading. It says, write a simplified algebraic expression for the area of the rectangle in terms of width. Okay, so they're saying use W for the width. Okay, so this up and down here is the width. The length, let's go back to this sentence. The length of the rectangle is 2 more units than its width. Can you tell me what goes down here for the length?
W plus 2.
You got it. Okay. Now the area is just like the area of a square. It's base times height. If you prefer length times width, that's fine. They're all correct. It's just whatever you want to, whatever you prefer. The more math you do, the more choices you get how you do things. So the base is W plus 2 and the height is W. Or W, yeah. Okay, so we are not done. We do need to simplify. We've actually not done one like this here yet, so we can work on this together. I'm going to rewrite it so that the W is there, and then the W plus 2 is there. So you actually just distribute in. W times W is W squared. W times 2 is 2W, and that's your final answer.
Okay.
Any questions on that?
No.
All right. 23. It's a very creative problem. We're now doing triangles instead of squares and rectangles. So always good to draw a triangle if you want. I think it's helpful to make the drawing. That's the height, and then the base goes all the way across here. Lots of different triangles you could draw. If you prefer a right triangle, that is also okay. It still has a base, it still has a height. All right. Okay, so let's look at this problem here. It says they give you the formula for the area of a triangle. It is 1/2 base times height. Base times height, cut it in half. Two triangles make a rectangle. That's why it's cut in half. If the base of a triangle has a length of 8x units, okay, and the height is x plus 6 units. So notice here they're just giving you the formulas. They say to write a simplified algebraic expression for the area of the triangle in terms of x. Now you're more of an art person, I think is what you said.
Yeah.
Maybe. Which triangle are you drawn more to? The one here on the left, or the one sort of more in the middle?
The one on the left.
Okay, so we'll use that one here. The base has a length 8x. So 8x is the distance from here to here. And then the height is x plus 6. That's from this, it's called the vertex, down to the base there. All right. So the area formula is 1/2 the base. The base is 8x, and the height is x plus 6. All right. So you ever found yourself in a math class and be like, you know what? We've never seen this before. This is totally new. You ever had that
Yeah.
happen?
Yeah.
This is actually a really good example of that, because we've actually not done anything like this up until now. Now, it's not that difficult to do, but it's, if you were to say to a teacher like, hey, we've not seen this, you would actually be right, because we have not. Like, we were doing binomials times binomials. We weren't doing, three things. All right. But we're going to get through this fairly quickly. So you start with the 2 on the left here. What is 1/2 times 8x, or what is 1/2 of 8x? What is
4x.
half of anything? Yeah, 4x. Good. And then you've got this x plus 6. Now, all this means is you're going to take this 4x and multiply it by x, and 4x times the 6. Okay, so will you do that for me and tell me what the answer is?
Or x squared plus 24.
Anything else?
Oh yeah, 24x.
Yes. Yes. That's it. That's your final answer for that one. All right, so we have some time left. Why don't we work on 18 next? Is that okay?
Yeah.
All right, so you're going to FOIL here. You're going to FOIL first times the first, outer, inner, last. So 6x times 6x is 36x squared. 6x times 5 is 30x. Minus 5 times 6x is minus 30x. Minus 5 times 5 is minus 25. So that's 36x squared minus 25.
Okay.
All right, so let's have you try, I don't think we did 10. Why don't you try 10 for us?
All right.
Work that out. Let me know what you come up with. Let me know when you get your answer for this one.
I got n squared minus 3n minus 28.
Perfect. All right. So there's a bunch that have not been done. Just pick one. Let me know which one you're going to work on, and I'll confirm your answer. Which one are you going to work on next?
11.
11. Okay.
I got d squared plus 20d plus 99.
Yes. Why don't you try, I don't know, is there any left that we have not done? 7?
Yeah, I'll do 7.
Okay.
I got 2p squared minus 5p minus 12.
Yes, perfect. Okay, very good. I'm going to stop the recording here.